Hello and welcome to another mathematics lesson. Today we'll be doing plane shapes and we'll be drawing different types of plane shapes, but we confine ourselves to triangles first. And this lesson is a grade 7 lesson. Now the materials that we'll be using to draw these shapes, particularly triangles, one of them is a protractor. This is a very instrument in measuring angles, knowing exactly the amount of degrees in a particular angle. We can also use it to draw any angle that we want. A protractor is a special instrument for measuring angles. It is called a protractor, as I said before. And then the picture here shows a typical protractor with its important parts labeled. As you can see, the origin here is at the bottom middle of the protractor. It is a very important point because you start measuring your angles from this point. And as we can see, the degrees are marked here from 0 to 180, starting from the right, coming over to the left, and from 0 to 180 on the other side as well. In two directions, in the clockwise direction and in the anti-clockwise direction as well. Okay. Now, different types of triangles. We'll be doing the various types of triangles. First, equilateral triangles. We shall discuss what are equilateral triangles and some of the features of an equilateral triangle. Second is an isosceles triangle. We shall also look into isosceles triangles and we will draw various examples of isosceles triangles. Scalene triangle. Again, we will look into scalene triangle and draw some examples. And a right angle triangle. We will also discuss right angle triangles and we will draw some right angle triangles as well. Now here is an important note. A triangle with two equal sides is called an isosceles triangle. Any triangle with two equal sides only, the two equal sides are equal, this is called an isosceles triangle. Again, the two equal sides being equal also makes the two opposite interior angles or the base angles equal as well. A triangle with three equal sides is called an equilateral triangle. When you have a triangle when all the three sides are equal, that triangle is called an equilateral triangle. And all the three sides being equal also makes all the three angles equal, wherein each and every angle will be 60 degrees in an equilateral triangle. A triangle with a right angle is called a right-angled triangle, as the name implies. A triangle with a right angle is called a right-angled triangle. Of course, any triangle that we see with a right angle is referred to as a right-angled triangle. A triangle with three sides with different lengths and no right angle is called a scalene triangle. In a scalene triangle, all the sides are different in length. And therefore, all the angles are also different in size. None of those angles is a right angle. And these sides will also be marked differently to indicate their difference in their length. Now let's try and draw different types of triangles by using a ruler and a protractor. What type of triangles are we seeing here? We are seeing different types of triangles, but then we are going to draw our own triangles. Okay, we draw a right angle triangle, an isosceles triangle, a scalene triangle, and an equilateral triangle. First, we can start with a right angle triangle. We shall start drawing with a right angle triangle. We can get our ruler. We have a ruler here. And suppose we say our line will be, let's say, our side of the triangle will be 7 centimeters. So this is the length of one side. Okay. Now we need the service of our protractor now. The protractor will help us measure our 90 degrees angle so we can have it exact. As I said, the protractor, the origin of the protractor should be on the line. And you can see the readings on the protractor. And the readings on the protractor, hence we want a 90 degrees angle. We will put a mark or a dot on the right angle here. And that will help us to connect. As you can see, this will help us to connect the dot to the beginning of the line or on the line, wherever it is, hence it's a straight line. We will obviously have our 90 degrees. So we move our protractor and then consult the surface of our ruler now. As we can see, all we need to do is move our ruler a little bit. And we can easily connect our line, our dot onto the line. Okay? As you can see, let's get our line. And this is a straight line for that matter. Okay. Now we can get our ruler. Again, to connect and draw one side of the triangle. And this would give us a perfect right angle This would help us draw our straight line to complete our triangle. And then as you can see, this is our right angle triangle. Now one of the things that will tell us that this is a right angle triangle is the indication of a small box here at the right angle, and this is all we can do to draw a right angle triangle. First, draw your straight line, connect your protractor, the origin of your protractor on the line wherever it is, and then locate the 90 degrees mark on the protractor. And if you do that, you can connect that point to any part of the triangle, and then draw your small box at the right angle. And this is how we construct, or we draw, a right angle triangle. Okay? Our second drawing would be an equilateral triangle. We said equilateral triangles have all its sides equal. All the sides of an equilateral triangle are equal. All the sides being equal also makes all the angles to be 60 degrees each. So we can go ahead and draw our equilateral triangle. We are drawing our right angle triangle. Drag back a little bit. let's say every side of the triangle would be 7 centimeters. That's our 7 centimeters mark here. Okay? And again, we need to make sure all the sides of the triangle are exactly 7 centimeters. Otherwise, we wouldn't have an equilateral triangle. All sides must be exactly 7 centimeters. Let's draw until it connects with the first line. As we can see, that's another side of that's one side of the triangle again. So we did both sides of the triangle. So now we are left with another side of the triangle, which will be, okay, we can move our ruler. Now we can draw our line such that we will have another 7 centimeters. Such that our line will be exactly 7 centimeters. Okay, so we draw a line across to complete our equilateral triangle. But there's something that is missing here. When we label in our triangle, our equilateral triangle, we need to mark all the sides identically. Okay? Mark them with the same stroke or the same line. If you choose to put one line or one stroke on all the sides, that's fine. If you choose to label all the sides with 2 strokes or 2 lines, that is also very okay. What is important is all the sides must be identically marked. Again, this is an equilateral triangle, and all the angles here in an equilateral triangle also are 60 degrees each, nothing less and nothing more. Okay? So next, we want to draw an isosceles triangle. An isosceles triangle, some of the features of an isosceles triangle is 2 of the sides are equal. 2 of the sides are equal, which also compels the base angles to be equal. Okay? The 2 sides must be equal in length, and the base angles also are always equal in size. Okay? So we move on with our isosceles triangle. We have to measure. We need to make sure both sides are equal. So let's say this is the base, and then the base happens to be 9 centimeters, okay? The base happens to be 9 centimeters, okay? If you have here as 9 centimeters, you can take a pen and then write 9 centimeters. That's 9 centimeters, okay? And the 2 sides, let's say 2 of the sides equals to 10 centimeters. The 2 equal sides must be equal to 10 centimeters, if you want. The 2 sides, we say shall be 10. Let's see if this is possible. Or we can even make it 8. There we go. We still can move our ruler and then draw an 8. Can move our ruler still. Can move our ruler still and draw 8 centimeters as we did before. So as you can see, both sides are 8 centimeters each. Okay, both sides are 8 centimeters each, and these sides should also be marked identically, normally with a 2-stroke. Okay, whether we label them or not, we will obviously know that these two sides are equal, because if here is 8 centimeters, if you have 8 centimeters here, here also would be 8 centimeters. Okay, this is a perfect example of an isosceles triangle where the two sides are equal, 8 centimeters each. These two sides being equal also make the base angles to be equal as well. Okay, as we said, this is a perfect example of an isosceles triangle. Now we move on to the last one, that is a scalene triangle. We said the features of a scalene triangle are it doesn't have a right angle, none of its angle is a 90 degrees angle, and none of its sides are also equal in length as well. They are all different. All right? So we can easily get our ruler. Okay. We can get our ruler and then quickly draw our scalene triangle. All right? Let's measure in centimeters. Okay. So let's say let's draw, and we can say this is 7 centimeters. One of the sides is 7 centimeters. And another side also okay. You can draw another side. Okay. Let's see. If we happen to have here as 7 centimeters, let's have this side as, say, 8 centimeters, as you can see on the ruler. Okay, whatever we have it as, but let it be not the same as the previous sides. Okay, so here we can connect one side of the triangle, and as we can see, it is 4, or let's say a little bit less than 5. You can still take it as 5. The idea is let it be different. So this is 8 centimeters. This is 8 centimeters, and this is 5 centimeters. All the sides are marked differently. Okay, being the longest side, we can say let's mark here with 3 strokes or 3 lines, here with 2, and here with 1. So this is a typical example of a scalene triangle. Okay, just a quick review of all the triangles that we had. We said this is a right angle triangle where one of the sides is a right angle, and then we have an isosceles triangle, an equilateral triangle where all sides are equal and all the angles are also equal to 60 degrees. We also have an isosceles triangle where both sides are, 2 of the sides are equal, only 2 of the sides are equal. And we finally get our scalene triangle where none of the sides are equal in length and none of the angles are also equal in size. Okay. So another triangle, these are another types of triangles. I mean, a group of triangles, as I can say. All these are triangles. And as you can see by looking, by inspection, you know they have the features of a triangle, which is they have 3 sides. Okay, and looking at them, you may conclude that this is an equilateral triangle, even though the sides are not identically marked. But what is important is to observe and then conclude that these are all triangles. We have various types of triangles here as well. We can see these two are examples of right angle triangles. Because of the small box here at the right angle, that indicates that this is a 90 degrees angle. Then, and any triangle that has a 90 degrees, one of the angles has 90 degrees is a right angle triangle. These two are right angle triangles. We can conclude that this is an example of a right angle triangle, not very sure because the right angle is not marked. So the indication, the most important indication here is the box at the right angle. That indicates that this is a right angle triangle. Comparing and describing triangles now. Now we need to compare the various types of triangles. We already know their features. We can use these features to identify them and to compare them with other triangles, whether they have some similarities or whether they have established their similarities and also indicate their differences as well. Okay? It is when two or more sides of a shape are equal in length. When two or more sides of a shape are equal in length, we saw this using short lines on the equal sides. When the sides are equal, make sure the sides are identically marked. When they are different, let them be differently marked as in scaling triangles. Okay? Now we use the following triangles to answer the questions that follow. Now, what type of triangle is this? As we can see, all the sides are identically marked. That tells us that all the sides are equilateral, all the sides are equal, hence they are identically marked. And when we have a triangle when all the sides are identically marked, that tells us that all the sides are equal. And if all the sides are equal, it is therefore an equilateral triangle. As you can see here, all three sides marked the same way, which tells us that the three sides are the same, they are equal in length. Therefore, the triangle, we conclude that it is a right angle, it is an equilateral triangle. Now we have figure B here as well. This is also an example of a right angle triangle, as one of the angles is a right angle. It doesn't matter how this is drawn. Sometimes it could be flipped, sometimes it could be turned upside down or a little bit diagonal, but what is important is the right angle. Whenever we notice that one of the angle is a right angle triangle, then we can conclude that it's a right angle, then we can conclude that this figure is a right angle triangle. Which triangle has only two sides that are equal? We've talked about triangles, and here comes a question. Which triangle has only two sides equal? We said before that isosceles triangles have its two sides equal. Only its two sides are equal. The second question is, which triangle has all three sides equal? Which triangles have all three sides equal? As we discussed before, equilateral triangles have all its three sides equal. Again, another question is, which triangle has an angle equal to 90 degrees? We said a right angle triangle have one of its angle as a 90 degrees angle. Therefore, the triangle is named after that angle, which is why it is called a right angled triangle. Now we have a question here. What is this type of triangle called? What is this type of triangle called? As we discussed before, first let's study this triangle and see. You can see two of the sides are identically marked. And we said, why are these two sides identically marked? Because they are equal in length. So long they are equal in length, they should be marked identically. As you can see in the figure here, they are marked with two lines or two arcs. So that indicates that side ED is also equal to EF. And when two sides of a triangle are equal, we said it is an isosceles triangle, because those are the main features of an isosceles triangle. So we conclude that this triangle is an isosceles triangle. Why? Because two of its sides are equal. As I said, ED or DE and EF are equal. So if DE is 70 millimeters, therefore EF is also 70 millimeters. This is an isosceles triangle. Which triangle have all three sides equal? Which triangle have all three sides equal? Now we have a triangle here. As we can see, all the three sides are marked identically. That indicates that all the three sides are equal in length. And if all the three sides of a triangle are equal in length, we say it is an equilateral triangle. Equilateral lines are equal. So if AC is 12 millimeters, we can say BC is also 12 centimeters, and AB is 12 centimeters. They are all equal in length. What is this type of triangle called? We have a triangle here where all three sides are marked differently. All three sides are marked differently, and the longest side is 55 millimeters. That is GI. HG is marked different from GI, and HI is also marked differently from GI and GH. So we therefore conclude that this is a scalene triangle because it bears the features of a scalene triangle. None of the sides are equal in length, and therefore none of the angles are also equal in size. All right? And as we can see, all the sides are marked differently, showing that there's no similarity or there's no feature that all these three sides share. So we conclude that this is called a scalene triangle because it bears the characteristics of a scalene triangle. Now we move on. The shape below is a triangle. It's very obvious. I mean, this is a triangle. Give a reason for each of your answers. Wherever we answer a question, we have to give a reason to our answer. Now, the questions are as follows. Is this triangle scalene, isosceles, or equilateral? Is this triangle scalene, isosceles, or equilateral? Now, observing the triangle, we realize that it doesn't have features of an equilateral triangle wherein all sides should be equal, because all sides are not identically marked, so therefore they are not equal. Does it have a feature of a scalene triangle where all the sides will be differently marked because they are not equal in length? No, it doesn't. But it does have a features of an isosceles triangle wherein two of the sides are equal. How do you know the two sides are equal? Because they are identically marked. We can conclude that side JK is equal to side KL. Okay? So therefore, if KL is 6 centimeters, then JK equals to 6 centimeters as well. So we can easily conclude that JK is equal to KL. Okay? Now if KL is equal to 6 centimeters, then we can conclude that JK or KJ equals to 6 centimeters as well. Okay? Now the reason to our answer is, this is an isosceles triangle. The reason to our answer is two of its sides are equal. Okay? As we can see here, two of its sides are equal. But it's also a right angle triangle. Okay? Although that doesn't come in the options, but it's also a right angle triangle because one of the angles is a 90 degrees angle. Okay? So that concludes our lesson. I thank you so much for your kind attention. See you next time.